In this session, we will discuss about first shifting theorem or S shifting. If f of t has the transform f of s, that is, if L of f of t is equal to f of s, then L of e raised to at into f of t is equal to f of s minus a. It is called S shifting. If f of t is L of f of t equal to f of s, then L of e raised to at into f of t is equal to f of s minus a. Similarly, we can say that L of e raised to minus at into f of t is equal to f of s plus a. L of e raised to minus at into f of t is equal to capital F of s plus a. Look at the problem. Find L of e raised to at into cos wt. So, using a shifting theorem, we can easily find out its Laplace transform. Here, e raised to at into cos wt. Therefore, f of t is equal to cos wt. So, first we have to find out L of f of t, that is L of cos wt. L of cos wt is equal to, using the basic transform, it's using the standard result, we can write down it as L of cos wt is equal to s divided by s square plus w square. That is our f of s. Therefore, L of f of t, that is L of cos wt is equal to f of s is equal to s divided by s square plus w square. Therefore, using shifting theorem, L of e raised to at into f of t, that is L of e raised to at into cos wt is equal to f of s minus a. Here f of s is s by s square plus w square. Therefore, f of s minus a means replace s by s minus a. That is, s is replaced by s minus a, s square is replaced by s square, s minus a all square plus w square. Therefore, the Laplace transform of e raised to at into cos wt is s minus a divided by s minus a all square plus w square. Next is a general problem on Laplace transform. Given the here the function is given. Here the function f of t is a discontinuous function. F of t is equal to t when 0 to 1 and 1 when t greater than 1. So, using the standard formula, that is L of f of t is equal to integral 0 to infinity e raised to minus st into f of t dt. That is equal to, since f of t is a discontinuous function, we have to split into two. That is, in the interval 0 to 1, it is function is t. Therefore, it becomes 0 to 1 e raised to minus st into t dt plus in the interval t greater than 1. That means integral from 1 to infinity, the function f of t is 1. Therefore, it becomes e raised to minus st into 1 dt. Using UV rule, we can easily find out the first integral. Take t as the first function. Since t is a polynomial, therefore we can apply UV rule. Therefore, taking first function as t and second function as e raised to minus st, applying UV rule, first function into integral of second one, that is e raised to minus st divided by its derivative of minus st, that is equal to minus s, minus derivative of first function is 1, is integral of the second function is e raised to minus st divided by minus s into minus s, that is s square. Then applying the limits 0 to 1 plus integral of the second term is e raised to minus st divided by minus s. Limits are 1 to infinity. Then applying the limits, we use only the result e raised to minus infinity is equal to 0, and applying the limits we can find out the Laplace transform of f of t is 1 by s square into 1 minus e raised to minus s. Then next is change of scale property. Change of scale property says that if L of f of t is equal to f of s, then L of f of at equal to 1 by a into f of s by a. L of f of at is equal to 1 by a into f of s by a. Look at the problem. If L of f of t is equal to a by s square plus 4, find L of f of 3t. Here, what is L of f of t? It is f of s. Therefore, L of f of t equal to f of s is here a by s square plus 4. Here, you have to find out L of f of 3t. So, the value of a is 3. So, using the change of scale property, L of at. What is the formula? L of f of at is equal to 1 by a into f of s by a. Here the value of a is 3. Therefore L of f of 3t is equal to 1 by 3 into f of s by 3. Then here f of s is a by s square plus 4. Therefore f of s by 3, to find it is replace s by s by 3. So it is 1 by 3 into a divided by s is replaced by s by 3 all square plus 4. Simplifying, we get L of f of 3t is equal to 3a plus s square plus 36. Okay, next look at some problems on Laplace transforms. Find L of cos wt plus theta. Then what is cos a plus b? Cos a plus b is cos a cos b minus sin a sin b. Then apply it. We get L of cos wt cos theta minus sin wt sin theta. The function, here we take f of t, it is a function of t. Therefore cos theta is a constant in this case. So we can take, applying the linearity property of Laplace transform, apply the linearity property to here. Cos theta is constant, therefore we can take cos theta outside, therefore it becomes cos theta into L of cos wt minus, it is also a constant, therefore we can take it outside, sin theta into L of sin wt. Then apply the standard results. L of cos wt is s by s square plus w square, sin wt is w divided by s square plus w square. So in the following problems, applying the basic trigonometric relations and linearity property of Laplace transform, we can find out the Laplace transforms. Next, look at the problem here. So in some problems, the graph of the function is given. Here graph of the function is given. Look at the graph. In this graph, it is a unit step function. 0 to 1, it is point 1. 0 to 1, the function value is 1. It's a constant here, 1. And 1 to 2, the function value is minus 1. So first we have to write what is a function here. So f of t is equal to 0 to 1, it is 1. 1 to 2, it is minus 1. Then apply the general formula. L of f of t is equal to integral 0 to infinity e raised to minus st into f of t dt. In 0 to, split the interval into 2, that is 0 to 1 plus 1 to 2. In 0 to 1, f of t is 1, therefore it becomes 0 to 1 e raised to minus st into 1 dt plus 1 to 2, f of t is minus 1, therefore it becomes 1 to 2 minus 1 into e raised to minus st dt. Then integrating and substituting in limits, we get the final value 1 by s into e raised to minus 2s minus 2 into e raised to minus s plus 1. Also, consider the last problem in this page. Look at the problem. Find the Laplace transform of the function here. Here the graph is in 0. Here the point is 0. 0 to 1, the graph of the graph is the line joining the point. 1 means, here 1 means is the point 0, 1, and this is the point, x value is 1 and y value is 0.5. Therefore this is the point 0, 1 and 1.5. Therefore in the interval, in the function is defined in the interval 0 to 1, is a graph is a line. So to find the f of t, first we have to find out the equation of the line joining 0, 1 and 1.5. What is the equation of the line joining x1, y1 and x2, y2? It is x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1. But here instead of x, the variable function of t, that means the variable is t. So we use, instead of x, we use the variable notation t here. Therefore y minus y1 is 1, y minus y1 divided by y2 is 0.5, 0.5 minus 1 is equal to, instead of x, t minus, first value is 0, second value is 1, therefore 1 minus 0, apply, we get y is equal to 1 minus t by 2, that is f of t. I means function, f of t is equal to 1 minus 1 by 2 into t in the interval 0 to 1. Then applying the general formula, L of f of t is integral 0 to infinity e raised to minus st into f of t dt. We can easily find out the Laplace transform of the given graph.